All right, so Per, we're gonna take a test drive in your car, right?
Yeah.
And we're gonna go to a location where we can get better shooting in sun.
Yeah.
And see how it
space.
goes. Yeah, it's more space. Okay.
Yeah, let's go.
When you're ready. So when did you buy this car?
I bought it about 3 years ago.
Mm-hmm.
Yeah, a little over 3 years ago. I saw an ad on the electric car forum here in Sweden. A guy was selling his project car. It was a car that was missing the controller, the ECU. It was missing more or less every part except the motor and the transmission. So I thought maybe this could be an interesting project to start with, because I was thinking about doing a real conversion at first, but I thought I'll start off a bit with something a bit more easy to use with, to start with a car that's already electric drive but just has to get some new batteries or but I didn't know what I was buying before I bought it. So, some of the main main cables in the car had been cut. So I had to get one of those cable harnesses for that connects the ECU to the rest of the car, and luckily I found one, but
now this wasn't new, of course. You had to buy it off of someone else. Had a bunch of parts for these cars, or?
Yeah, there some of the salvation yards has some parts, but mainly it's just people that has been lucky enough to get parts from cars that has been wrecked or that is missing batteries, or it's just like standing somewhere. People owning cars but just
not doing anything with them. So how long did it take for you to I guess get it into a running condition?
It took almost a year to do that. But I would say that, yeah, of course, getting all the parts together was one thing that took time. I had to find the throttle sensor and everything like that, because it was missing from this car. It had been the previous owner had tried to use a Curtis controller in it, but he didn't get it to work properly. So
because it's a CPEX motor in here.
Yeah, it's a CPEX motor from ABB that was taken to this car from the original design. So they actually, ABB contracted a Norwegian company to do the controller, and then I guess Renault just bought the controller and motor package from ABB, and they made it that to a rebuilt gearbox from their standard gearbox selection from their like normal Clios, which was a manual transmission. So they just kept one of the gear sets instead of having 5 sets of gears. So it's a fixed ratio of 1:8.
And it works pretty good for you. You don't have to you don't have to shift gears at all, and go. It rides really nice.
Yeah, it's nice, but it's a bit limited in speed. So that's the only thing that I miss. I could take a little bit more speed. It's doing about 95 kilometers per hour top speed, but I wish I could do 120 at least.
Well, you made some sort of attempt to bypass all the normal engineering in the car, right? And get more power out of it?
Yeah, but that wouldn't have helped to get more speed, because the speed is limited by the controller. It has a pickup on the motor, so it senses the RPM all the time, and it actually uses the region of the Zepex to limit the RPM of the motor. So it will never spin more than just below 8,000 RPM.
Okay.
So that wouldn't have helped, but I tried to get it a bit more powerful at least. But yeah, we can see the results of that later.
Yeah. Okay. Perfect. So originally the batteries that were in this car were nickel cadmium or lead acid? Okay, nickel cadmium. And you used those, right? For a while?
No, I didn't use any nickel cadmium batteries in this car. It was when I bought the car, there were no batteries at all.
Okay.
There were some lead acid, like UPS batteries that he tried to use with the Curtis controller, and he just left it in the car. And I just mainly used them to try to check that the controller was working and stuff like that, trying to get the charger to work, because I didn't have the lithium pack to start with, so I just connected like 10 lead acid batteries.
Just for power to test everything
just to
else,
test.
So now you have how many lithium batteries in here? What size?
There are 160 amp hours, and I have 40 of them, so I have like a nominal voltage of 128 something. Let's see what we have right now.
And so this is the instrumentation that came with the
yeah,
car.
this is the original instrumentation. Volts right now.
131 volts.
Yeah.
Let's see. Why don't you go through the screens and we'll see.
Yeah, we'll start from the beginning then.
So okay, we'll start.
This is the start picture that you get, and it shows how many amp hours you've got left, and then you have a screen with the average amount of amp hours drawn by every 10 kilometers, and also the estimated range by that to the next time I have to plug it in.
Okay, so the bottom number is your range.
Yeah, that's a 53 kilometers.
Okay,
is what it predicts me to be able to go.
Okay, now this whole system is based on the NiCads that used to be in here.
Yeah.
Okay.
Yeah.
So it's a little skewed because it doesn't understand lithium.
Yeah, the computer in the ECU tries to correct for the NiCads because of their lower charge retention and also the way the self-discharge that the NiCads has. So it will actually subtract the amp hours without me even using the car because of the self-discharge. So,
because it thinks that you're losing power no matter what. Yeah.
And then we have the momentarily amp draw and the range, or the number of kilometers that I have driven since the last time I
charged the car
fully.
Okay.
Yeah. And then I have the amount of amp hours since I charged fully, and also the accumulated number of amp hours charged in and out of the battery.
Okay.
So every time I charge, I get the charged amount added to this number.
Okay.
But I cannot say that this accumulated number is accurate because I didn't reset that when I got the lithium batteries in the car. I should have done that to know how many amp hours I have.
And now that you've had them in here for 2 years, right?
Yeah.
Okay. So who knows how many
Yeah, I'm not sure really. And then there's the picture for a heating system that I could program the heater, because the car has a water heater that heats the water system, so I could use the normal heater, cabin heater in the car. So
and that's a fuel heater?
Yeah, it's a fuel heater.
Okay, so it uses gasoline?
Yeah, gasoline, or I'm using bioethanol at this moment.
Okay. And so what's the rating on that heater?
It's a 4 kilowatt heater.
Okay.
And it takes about half a liter an hour to run it, so.
Okay.
There is a gas tank, especially for the heater, that takes 8 liters, so I can run at least 16 hours. That's more than 1,000 kilometers, I think, heating.
And of course, you only use that during the winter time, so
yeah.
You know, it's not a big deal.
Normally, I just use I have a heated seat blanket, and I have a cabin heater when I'm parked, so I can put that on and get the cabin warm, and then I don't have to use the heater that much. But for long drives, when the cabin gets cold, I have to use the cabin heater. So.
Okay.
I have been thinking about converting it to electric, but I feel that the range is a bit more interesting to me than to be totally independent of the fuel, because I see it as I use bioethanol. I'm not using that much fossil fuel anyway, so. And it's a good way to keep the cabin warm.
Yeah.
And then we have a special menu here that only the older ECUs for the car can have, and that's like a kind of I think like a maintenance menu for the shop, repair shop. It gets your revision of the ECU, and you can get you can read values from the black box memory of the ECU, where it stores information about the number of amp hours used and how much energy you have, and you can also actually update data here, reset data for the like for the accumulated amp hours charged and discharged. Here's a picture that is supposed to show the amount of current drawn by the DC to DC converter and the voltage on the 12 volt bus, the output from the DC-DC. But it's shown in hexadecimal numbers, and I'm not sure that it actually is correct. I haven't found out the way to find the
verifying what the codes are for.
So I'm not sure what it says. This is actually some kind of way to show different inputs to the ECU. So if I, for example, turn on something, you can see that the number changes, and if I turn it off, it changes back. So I guess that it is a way to see that inputs to the ECU is working, so all the sensors and stuff are correct. I'm not sure what the numbers are representing, but yeah. And the same thing with the outputs. So you can see that there's a number changing here somewhere. Yeah, this one. And that, I think that is the ground fault check. There's a check down by the ECU to check that you don't have any ground creepage between the main pack and the frame of the car.
Okay.
And you can hear that the ECU does a ticking sound all the time. And that's that check. Then we have a picture for the heating system. It shows the phase of the heating, if it's starting up, if it's burning correctly, if it's slowing down, or if it's turning off, things like that. And you can also see the temperature of the heating, or the liquid in the heating system. There's the T there is temperature, and the I is the momentary current. And then you have a picture with the voltage and the current.
So right now we're taking out 2 amps out of the pack right now.
Yeah.
That's why it shows a negative number.
Yeah.
And then when you have your regen active, it's a positive number.
Yeah.
So it shows
and also on the side here we have like bars showing the amount of energy used. If I kind of push the throttle here, you can see that it goes up. Or if we take a drive, we can see that the bars grow the more current you use. And if you use a regen, it
goes down on the negative, the bottom side. Yeah. All right. Is that all that's on the screen?
Yeah, that's pretty much it. And then you have the normal speedometer, and there's like a fuel gauge. But that's the problem with the fuel gauge. It doesn't work that good since it's calibrated for the NiCads and tries to correct for that. So I have to know roughly how far I've driven and use the odometer to know how much range I have until I get a real amp hour counter, and I'm about to do that soon. So
now I got only 2 questions. How long does it take to charge, and how far will it go?
Well, if it's totally flat out of energy, it would take about 10 hours to charge full, because the built-in charger is a 10 amp draw from 240. That I can go up to 16 amp draw from 240, but the charger has proven not to be that reliable in 16 amp mode. So I tend to use only the 10 amp mode, and that gives me about 15-17 amps to the pack, and that results in about 10 hours
total from
zero.
So your average charge? Well, you come home and you plug in at night, and you wake up in the morning and it's good to go.
Yeah.
I mean, okay.
I don't even know my average charge time because
it hasn't ever mattered. Yeah.
No, I just plug it in, and then the next morning it's done.
Well, this is your daily driver, then,
Yeah.
And you've been driving it for 2 years reliably.
Yeah.
So it took you a year to refurbish it, and then and so you've had the car for about 3 years, or a little over 3 years. Does your wife like the car?
Yeah, she loves the car, as long as it works the way she wants it.
Yeah.
Yeah. Mostly, she's had some problems, mostly with the heater.
Okay.
Because the heater has been a bit unstable. It has been working sometimes that it has been getting too hot, so the water starts boiling, and you get into a big cloud of
steam
coming out of the car, and so it's been mainly problems with the heater. But besides from that, the car just runs. You charge and it runs.
And that's what you need it for anyway.
Yeah.
So.
Yeah. And the range. I haven't tested the range totally, because I had the cells top balanced from the start and used a BMS from the beginning, and that BMS wasn't doing a very good job. It was a do-it-yourself BMS, and I hadn't done my homework really before I put it together. Mm-hmm. So probably I messed a bunch of stuff up and got it not to work properly. But anyway, since then I haven't touched the batteries, because they got really good balance at the top at that time, and I don't want to mess with it right now. So I just use the standard charger for the car that I have done a small circuit to be able to use it for the lithium, because the charger has a good profile. It uses constant power mode to start with, so it's always drawing 10 amps from the line, and then depending on the pack voltage it can output a different amount of current. So and it also tapers off at a certain voltage, so I just had to make sure that voltage was suitable for the lithium iron phosphate cells. So right now I'm charging my 40 cells up to about 145, 146 volts, something like that. And that's just below 3.7 per cell. So I'm actually thinking about adding 2 more cells and keeping the charge voltage the same to lower the charge per cell. But the furthest I've driven any time is 135 kilometers, and I wasn't babying the car at that time because I was late. I had forgotten things and I had to be somewhere in time. So I have got at least 135 kilometers, and from my calculations at that time I still had 20% left, so that was within the safe zone. But it was with the regular tires, but it was in the fall, so it wasn't that warm. So that could affect the batteries, but yeah.
Okay.
I have at least 135 kilometers with the summer tires.
Okay.
With the studded, I don't know. Really.
Okay. Well, let's take a look at the outside of the car.
Yep.
The original charge port for the car was what type?
Well, I'm not sure if it has like a standard name for it, but we always call it a Marshall port because that was the name of the company doing the plugs, and it's like a glove that just slip into the tracks here and just push it down. So this is the charge port. It's got a couple of connectors. This cable is not fully equipped with all the cables, but the system, the charge port, is actually capable of doing high current DC charging also. And there's receptacles for that in the car also. The connector is only good for one phase 240.
Okay.
But it's possible to equip it with three-phase 400, or to use also high current DC.
Okay. And are you able to plug it in real quick and show people
Yep.
how that works?
It's really hard.
Yeah, that is incredibly difficult.
And then you can also close the lid, and when you lock the car, it locks the lid also.
Huh. Fantastic. Okay. And then it comes out just as easy.
Yeah. You have to push the button though.
Okay. Very neat.
That's it. This is the charger. and it's connected straight to here for a fuse block here that goes to the main pack cables. The box here is the motor controller, and below that is the actual motor with the blower in front there.
So this is the forced air cooling.
Yeah, that's the forced air cooling. There's no fan inside the motor, so it's forced air. And it also cools the controller because the cooling fins are between the motor and the controller, so the fan
just blows across both of them.
Yeah. This is the power steering pump, which is not used at the moment because it takes a lot of power from
it's electrical power steering.
Yeah.
Pump? Okay.
And it's really noisy. This is the DC to DC converter. It's not in the normal position for this car. It's supposed to be underneath one of the headlights here, inside the fender almost. But that's a really bad position with regard of dust and water and spray. So I moved it up here to the engine bay instead. Instead I put the vacuum reservoir for the brakes down there instead, because that's just a plastic reservoir. So it wasn't
Ball right there.
Yeah. Then you have next to the DC to DC converter is the vacuum pump for the brakes. Just right here. And yeah.
So you have a lead acid battery down there for your...
Yeah, that's the 12 volt battery.
Okay.
Then yeah, normal stuff for a car.
So there's your
Brakes.
throttle?
Yeah, that's the throttle. So I have a normal throttle cable from the pedal, and then there's a Hall effect sensor here that goes straight to the controller, and it's got some marker switches also to determine full or if I have lifted the foot off the accelerator. So
Okay.
So
it can engage regen and everything.
Yeah. And then this is the reservoir for the heating, and it got some hoses going down to the heater that is mounted below the charger on the back side of the motor. Actually, that box has a couple of relays and a DC to DC converter from 12 volt to 24 volt, because I use that to fool the charger into believing that it's charging the batteries full, because the charger is set to taper down at 172 volts, but that's way too high for the lithium iron phosphates that I got.
So you're padding the voltage so that it thinks it's reached it
so
faster.
the charger thinks it's doing 170, but it's doing 140. Actually, the ECU, which is situated here, actually does the voltage measurement of the pack and communicates that to the charger by serial communication. So what I'm actually doing is fooling the ECU to send false data to the charger. But
so in effect, the ECU is kind of a BMS by controlling the charger.
Yeah, it is in some way. Yeah.
Now you have a couple cables tied up here. And what were they?
That's the high current DC voltage charge cables that comes from the charge port. I haven't reconnected them back to the fuse blocks here or the bus bars here. I don't have any possibility to do any DC fast charge with this car, because there are no fast charges around here. So
And are you going to configure your car for CHAdeMO?
I would love to, but I guess it's quite difficult to get the CHAdeMO specification and do some kind of interfacing between the CHAdeMO charger and the battery pack. But I would love to do that. Yeah, you can see that the controller was produced in 1997 in week 50. So that's a late model controller. That controller is actually from the other car that I'm trying to get running. Down here is the current sensor for the that the ECU uses to track the current in and out of the battery pack, and that's also the standard current sensor. So like almost everything here is from the series production, all the small series production, because there wasn't a big series of this. But
do you know how many cars were produced?
About 1,000, I think. Some 300 cars came to Sweden.
Okay.
Both these Clios and also the like the utility van called Express, small utility van. They were also NiCads, but a different size NiCads. They were 140 amp hours. These had nominally they had 114 volts. 100 amp hours of NiCads, but they were all gone when I bought this one. So yeah, on the original car with the NiCads, they were water cooled, so every battery block had its own water cooling jacket, and that was pumped through a normal radiator here in the front. But since I'm not using the NiCads, I could remove the radiator, so I opened up quite a lot of space here, and also got rid of some weight. Just the amount of water in the cooling system was about 7 to 8 liters, so that's just the water in the cooling system was 8 kilos. So
wow.
Then all the plumbing for the cooling also, and the radiator, and the radiator had a fan and also a pump to pump the water and stuff like that.
So where do you put all the batteries in this car?
Well, the batteries are placed in 2 boxes, and that's also from the original scheme of placing the batteries. They were placed underneath the back seat. But they were placed from underneath the car, so the car was actually closed up here, and there was no way to get to the batteries from inside the car. So the previous owner cut the floor open here to be able to monitor the batteries better, and also to be able to move them in and out of the battery pack. But the original battery box was just a frame, so it wasn't closed. I have had a box manufactured, and I have put the batteries in closed boxes now.
And you have a little insulation there?
Yeah, there's 1 centimeter of insulation both underneath, on all the sides, and one on the top also.
So these battery boxes are manufactured by a gentleman in Stockholm?
Yeah, he did a drawing for it and measurements for the car, so it's actually made especially for the Clio car.
Nice.
And he has done like 15 of these boxes, I think. So you can you can buy the kit for this box, and you just have to pop rivet it together and glue it together, or if you have a weld that could do a spot weld, you just spot weld it together, and it's a perfect fit for everything in this box, and it fits the car like magic.
And so you strapped your batteries together here with the Thunder Sky straps?
Yeah, it's just that I didn't know what kind of configuration I would use in the car, so I didn't order them pre-strapped in the way that they are now. So I had to do my own straps, but keep the sides. So because they were all delivered in 4 packs, so, and these are packs of 3, and in the back box I have packs of 7.
Do you have Nordlock washers on here?
Yeah, on all the terminals I have Nordlock washers, and also on the contactors that are between the batteries here.
See, so there's supports in there for the battery wall, the box wall. Oh, those are cables going through.
Those are actually the brake cables for the parking brake that's stupidly drawn straight through the battery box, and that's the original design, so we had to take that into account when doing the boxes. It's a really stupid way to do it because, yeah, you could have used that space for more cells instead.
Yeah. Again. So you have.
Yeah, I only have one of these braided straps because there's a different measurement between the
Terminals with 2 batteries.
Yeah,
and
when you have them like that. But so you can't use the same straps from going that way to going sideways. So, and I only have one of these, so I'm gonna get some more and put on the other ones that are the same. So right now I don't have a fuse because I blew that in my attempt to get some more power out of the controller. But yeah.
So with the temperature and the performance of the batteries, you said when you had them they were open box. You noticed it.
Yeah,
you
they
really
would
see the
sag.
difference.
They would sag more, and they would never heat up the way they do with the closed boxes. I used the car in minus 25 degrees Celsius during the winter with the open boxes, the first winter, and now this last winter with the closed boxes, the difference was quite
significant.
noticeable.
Yeah. Now this is a box that's also manufactured by the same guy?
Yeah, it's
Okay.
it's the kit with the 2 boxes. So.
Okay.
So it's just an aluminum lid, and then the rest is like galvanized steel, different thickness. And this is the rest of the Thunder Skies.
So that's a pretty good weight balance on the car you have, because you only have the electronics and the motor up front, and then the batteries in the middle,
Yeah.
and them.
I don't know the actual balance of the car, but or the weight distribution, but it's quite okay. It handles quite okay.
You're gonna get the braided straps for all these batteries, or?
Well, I don't think so. I haven't had any problems with the solid straps, so
Especially with the Nordlocks, right?
yeah, I'm just gonna switch these ones that are not real straps right now. That are more like cables. So that's my main goal, I think.
Oh, so these cells are numbered, I see, in some form.
Yeah, that's the standard number that came on the. That's the production number. I haven't done anything else. Those small letters there, they're. I think that's from the factory also. I haven't done any. I didn't do any measurements or anything on these before I put them in the car, and that's one of the things that I kind of regret. I would have wanted to do some charge and discharge tests before I put them in the car, but I didn't have the charger or discharger to do that at the time. So.
But now you actually have a battery lab, and you do some of the tests on your other batteries.
Yeah, I do some tests now, but I mean that I didn't have that 2 years ago when I put the car together.
Right.
It's just an interest that grew, and it fits just perfect on the battery box, and it's just got a thin gas tank that resides underneath the battery box on the side of it. So and it goes to the normal fill cap. So
I'm gonna try this this Renault Clio out. So what do I do to start this, Per?
well, actually, you have to turn the key.
That's it?
Yeah, pretty much.
I can do that. Everything's on. All right.
Yeah.
So how far can I go on 75%? As far as we went yesterday?
Yeah.
Oh, that's pretty good. Okay, so all I have is reverse, neutral, and drive. So I'm in park right now,
Yeah.
and it doesn't have a parking lock system other than the parking brake here.
No,
Right.
the motor and the gearbox doesn't have any parking brake.
So we'll just let that go, and I can go now.
Yeah.
That's it. Okay. I mean, besides the winter tires, it's actually a pretty quiet car.
Yeah, and that's mainly because I have turned the motor fan off and also turned the pump for the power steering off, because they are really noisy.
You didn't have to do so much with a lot of instrumentation because it was already factory.
Yeah, the instrumentation was fine, but I had to do some detective work because a lot of cables had been cut. So in order to get the right sensors, to get, for example, the charging to work, because there's since the original car uses NiCads, it uses temperature sensors in the battery pack to be able to calculate the end voltage for the charge, and because it varies quite a lot with temperature on the NiCads. So I wouldn't get the charging to work at the beginning because I didn't figure out which cables that were missing and what kind of sensor that I had to use for them, and I was almost giving up on the charging part until I found an error in the documentation. There were ambiguity between two different documentations for the car. So I had been following one of the shop repair manuals, and in the other one there was a different pin out on the pins from the ECU, and when I changed that, it all started to work. So and it had to do with the fact that the NiCads has to be vented because they produce hydrogen and oxygen when they charge. So the car was originally equipped with venting fans to be able to vent that away, and they had to work for the charging to start. The ECU would make sure that they had to work. So the ECU would actually sense the amount of current used by the fan to know if it was working or if it was shortcut or if it was open circuit. So I actually I have put a fan on that cables just to be able to use the charger.
So it sees a fan load.
Yeah, it sees the fan load and everything's fine.
Now, you've actually had to try and re-engineer everything in this car to make it work because it had been gutted, basically.
Yeah. But I got a good knowledge of the electrical system in the car, and yeah, I probably know pretty much all about the cables in the car. So the motor is rated some 21 kilowatts or something like that, continuous. Yeah. But that's 5. I think the controller is only able to do that for 5 minutes. when I try it, I can get like 270 amps, battery amps draw. And at that time I have like 117 volts or something like 115. So that would indicate a bit more than 71 kilowatts.
Right.
But I mean, there's some losses, and so I'm not sure how much it actually puts out, but we put more in than 21 kilowatts. And it seems like the motor is well capable of doing the amount of currents that we do in this car, and also even higher voltages. It's a Zepex with interpoles and field compensating windings and really large comms. So there we have the voltage and the current. That's a pack current, but at these speeds that's the same as the motor current because of the Zepex way of working. So this is the my small battery lab or small workshop, electric workshop. I'm right in the middle of matching my new battery pack for the car that I'm restoring right now. I'm restoring another Clio, Renault Clio, and I have a selection of 120 Thunder Sky 40 amp hours that I'm going to arrange in the combination of 3 parallel and then 40 in series, so I would get roughly 120 amp hours and 128 volts. And right now I'm actually doing a capacity test of one of the cells. I have tested the capacity of all the cells like 6 or 7 months ago, and now I'm doing a cell again to see if I have lost any capacity just by storing them. I'm doing quite low current. I'm doing just to 1/8C because the charger that I'm using, or the discharger in this case, is only capable of 5 amps. So that's what I started with, and that way I had to keep doing 5 amps for the whole set. So I have already tested all the cells on the floor here, and to be able to match them properly. I got the iCharger 3010B there on the floor that I also used to do the charge and discharge tests, but since I started with the small charger, I had to do 5 amp discharge with that one also. It's just that I had 2 chargers to use. But right now I can do 30 amps charge and 30 amps discharge in up to 10 cells. So
it says NiCad there on the charger settings.
yeah, I'm discharging the Thunder Skies right now, and this GG Power charger and discharger only has certain settings for the lithium iron phosphate cells. It discharges to 2 volts, and I don't want to discharge the cells to 2 volts. I want to do them to 2.5 volts. So that way I go to the NiCad settings. I can set the end voltage in steps of 1/10 of a volt. So I can set the end voltage to 2.5.
That's pretty accurate.
It's the same program anyway. I'm doing 5 amps constant current until 2.5 volts instead of 2 volts as the charger is pre-programmed to do in lithium iron phosphate mode.
So where are you right now? On you've already charged this earlier today, and
we
you're in
have
the discharge phase.
Yeah, we have discharged 23 amp hours roughly, and we're down to 3.00 volts, and so we're heading for 2.5, which is practically totally dead with this light load. But that's the way I tested them the last time that I did them, so that's the way I want to test them now, to have the same setup. Maybe it's a bit warmer in here right now than I had the last time, but it shouldn't be that much difference, especially not at this low load.
Now, would this be a good way to, say, sort of automatically balance your cells, like bottom balance your cells?
Yeah, of course. I mean, there's these. At least this iCharger has a program for storage mode and for discharge mode of lithium cells. So you could actually. There's one program that does constant current down to a fixed voltage, and then constant voltage until a certain current. So just the way you would do a charge, constant current, constant voltage, you would do a discharge the opposite way, and then you would have a balanced or a fixed voltage. You would have a cell that is actually stays at that voltage. So I would say that having one of these RC chargers is pretty neat when you're trying to do this kind of matching, and even if you just want to balance your pack, if you have single cells in your series string, they do a good work, and most of them are totally accurate also. I mean, they measure 5 amp hour cells or 1 amp hour cells for RC, so they count milliamp hours. That's the accuracy of it.
Oh yeah, that's right.
So
I remember that now.
You could do, and you could also set them to discharge a certain amount of current, or amp hours. So you could set them up to discharge 50 amp hours, and then they cut. So I think they're great, and I mean that's about the most powerful RC charger that you can get now. It's capable of 30 amps in, 30 amps out, and the neat thing about this one is that it's actually kind of a two-way DC-DC. So you can actually have a lead acid pack that feeds this one, and when you do a discharge, it puts the energy back into the lead acid pack that you're feeding your charger from.
So you can sort of shuttle energy back and forth between your...
And it's about, I think I've read it's about 85 to 90% efficiency. So
well, let's see.
You
Go
lose
ahead and take it out of there.
You lose some, but still it's better than losing everything and just generating heat.
So you got banana plugs on the end there.
Yeah, that's the input. So it would take 4.5 volts to 38 volts inputs. So you could do with the 3 lead acids, 12 volt blocks, but some people has had a bit of problem because, I mean, lead acid isn't 12 volts. It's more like 13.8 or fully charged. So I have just used it with a 12-volt power supply, or with a couple of lithium cells, actually, making something. I think I used 5 cells or 6 cells powering it and restoring power from it. But right now I'm trying to restore my broken controller that let the smoke out a couple of weeks ago. And that's all the...
You fried all these MOSFETs.
Yeah, that's all the MOSFETs that's fried. These are a total of 24 MOSFETs, capable of 50 amps each, rated 200 volts. They weren't up to the task of doing 500 amps in the controller.
So this is the Clio controller that you burned up?
Yeah, that's the
From the
Clio
other one.
controller.
Oh.
It has 12 MOSFETs on each bank of MOSFETs. One bank doing the drive and one bank doing the freewheeling or regeneration, in case you do the regeneration.
So
this, yeah, this
MOSFETs
is
on each side.
Yeah, the MOSFETs are situated just like that one, but the full row here.
And then that's mounted to here.
Yeah, then it's mounted to these blocks that are actually the conductors, and then they are separated from the heat sink by an insulator. So these blocks of aluminum is actually the conductors for the one for the upper and lower bank.
That's a lot of black material on there. Is that supposed to be there?
No, that is actually the magic in the MOSFETs that has come out and
Coated everything.
yeah, coated everything.
Wow. So what did you do to burn that controller up?
Well, the controller has a shunt for the armature current that goes here, and that measures the current that goes into the armature of the motor. It has a small shunt for the field current, as it's a Zepex controller. I got a spare shunt and I doubled the shunt and that makes the resistance go into half, so the controller, the control board of the controller would read the current as half the current as it's actually putting out. So it was trying to put out double the current as it's supposed to do.
And did it work?
It worked for 1 or 2 days, but when I started driving it a bit more active and trying to push it a little bit, it didn't want to do anymore. So the controller is rated for 275 amps for 5 minutes and then 180 continuously. I was probably pushing I was pushing double that, so pretty much 550 amps for a couple of seconds. And
Wow.
I guess the MOSFETs just didn't cope with the heat created.
They gave up the ghost.
Yeah. Wow. So actually, the circuit board took quite a beating. Also, it kind of blew some of the
Traces right off the board.
Yeah. So probably I have to get a new board. I would like to get a board with thicker traces to be able to do the 500 amps that I want to do. But I guess I will just have to remove all the stuff from the board and try to make a copy of it and have a new board etched, because you can't find the spare parts for these. So at least not single boards like that. And if I'm going to do a new etching, it's just best to do double the thickness of the traces, or
Right, improve the
tries,
design, sure.
Yeah, try to do at least. And then I just have to try it and scope it and see if I can reach the 500 amps in a safe way. I've been looking at the Open Revolt design, and I'm probably gonna use the parts that they used in the Open Revolt
Motor controller.
Yeah. They did like 1,000 amps on 14 MOSFETs or something like that, so I think I should be safe with 500 amps on my 12 MOSFETs, with the correct cooling, of course. Otherwise, I'm interested in switching to IGBTs also. But that's the next step. Just have to get this one alive again.
So you're going to, you already have a customer, you said, for the Clio that you're refurbishing, the one you're going to fix this controller for and stuff.
Yeah, actually that controller is going to go back in my daily driver.
Okay.
And the controller that I have in my daily driver now is going to go back into the one that I'm refurbishing. So this is going to be kind of my tune-up controller.
And have a lot of fun testing
Yeah,
your new
so.
design.
I'm sure I'm gonna break something else, some shaft or some coupler.